Hey guys, this is Mr. Baxter. I wanted to take a look at an example from section 4.2. This is one that's similar to number 5 in the homework there. And it says, determine whether the mean value theorem applies to the function f of x is equal to -5 plus x squared on the interval from -2 to -1 to +2. And if so, find the points that are guaranteed to exist by the mean value theorem. So let's talk just a little bit about the mean value theorem and what that means first. Excuse the dual meaning there. But if we have some curve, let's say, oops, get to my pen here. Let's say we have some curve over the interval from some A to some B, like this. And it starts down here, and this thing is nice and differentiable, and it ends up here, right? So this point down here, that's going to be our function evaluated at A. And this point down over there, that's going to be our function evaluated at B. All right? So over this interval, as long as this function is both continuous, which means that you can put your pen down here and you can get all the way over here without lifting your pen. It's usually kind of a non-math way to describe continuous. And differentiable, which isn't as easy of a way to describe, but it means at every point we can differentiate it, and that also means that there's no kind of sharp points, there's no corners, no jagged lines, anything like that. It's all kind of smooth the entire way. There's no kind of going towards infinity, asymptotes, things like that. So we got this nice smooth curve going from here to here, and we have certain functions at this point that we have proven are continuous and differentiable. Certain trig functions like sine and cosine are polynomials, which is a whole big list of things that we look at all the time. Those are both continuous and differentiable, so those are good things. But these are things that are over really any real interval are going to be continuous and differentiable. All right, and what it means is that if I find the slope from this point to this point, so that is the slope that goes from this first point to this last point, so that is what, f of b minus f of a over b minus a. If I find that this slope here, that there is guaranteed to be at least one point in this interval, there's guaranteed to be at least one point in this interval that has the same slope. So if I take, let me use a different pen here. This is what the mean value theorem means. If I take the slope that goes from this point to this point, so let's say that's my slope there, that I can find at least, possibly more, but at least one point. There's maybe one right there. There's maybe one right there. But I can find at least one other point within my interval, so inside my interval, that has the same slope. I'm guaranteed by the mean value theorem. And we can find that by using derivatives, because we can find the critical values and set those equal to our slope of these points here and find it that way. And we're going to go through that process here. All right. So let's erase this part here. So that's kind of what we're trying to do. Back here. All right. So determine whether the mean value theorem applies. Well, -5 plus x squared, that is a polynomial because all the variables are fine. All of our exponents are two positive integers. We don't have anything else funny going on. Like we don't have any negative integers. We don't have any rational equations, anything like that. So we are good. This is a polynomial, so that means we're going to be differentiable and continuous on any open closed interval. So that's good. Mean value theorem does apply here. So now how do we go and find what this is? Well, let's first kind of take a look at this along this interval here. So I'm going to pull up the calculator. So I've already put this in here to save us a little bit of time. So if you go to y equals, I'm going to put this in here, the function in my y1. And then I'm going to go to my window, and I'm going to set my x-min and x-max to be identical to my interval here, and y-min, y-max, just -10, +10. I can change that later if it doesn't seem like it's working. And then graph this. And as you can see, it looks like it's coming here, so it's a little bit lower, and then it's kind of going upper, so I should be expecting a slightly positive slope here. Slightly positive slope. So where am I expecting to find an x value with the same slope? Maybe somewhere around, I don't know, 0.3, 0.4, 0.5, somewhere in there. Right? Doesn't that look like that probably has a similar slope, maybe 0.5? So, so this is what it looks like from a visual standpoint. So now let's actually do this here. So the formula is, well, let's first actually find the derivative here so we can do the critical value. So the derivative of our function here is nice and easy. That's just applying the power rule. The -5 zeroes out. So we just have 2x. And I'm going to actually change the x to a c, just since we're talking about the critical values, and I kind of matched the question help they have there. So this is 2c. So this is the equation for the slope of our tangent line here. And so I'm going to set that equal to the slope of the two points at the ends of the interval here. So it'll be this point here. Let me go back to here. So it's going to be this point and this point, that line that forms those points there. So this is how we're going to set it up. So f of b minus f of a all over b minus a is going to be equal to my 2c. And now I'm solving for c here. That's going to be my critical value. Alright, now I have b, that'll just be the end value of my point here. So b is going to be equal to 2. And a will be equal to -1. That's my first value there. So putting everything in here, so 2 minus a -1, that's +1 over here. And then f of b, so that's going to be, I've even done this beforehand, it's going to be this evaluated at 2, so that's going to be -5 + 4, so that'll be -1 minus f of a, so -5 + 1 is -4, so minus a -4, so that's +4, equal to 2c. Alright, so this is going to be 3 over 3, which is 1, is equal to 2c. So 1 is equal to 2c. So c is equal to 1/2. So about 0.5. So we were pretty close just by kind of eyeballing that there. So this here is the x value, in which case our that's the point that was guaranteed to exist by the mean value theorem. So at x equals 1/2, we also have, and we can actually find the y value there too by plugging it in there, right? So if you plug in that 1/2, what do we get? That's 1/4. So -5 plus 1/4 is going to be, I don't want to do that in my head right now, so let's go to the calculator here. So, oops. So -5 plus 1/4, 0.25. All right. -4.75. Let's put that in fraction form. There, -19/4. -19/4. And that's pretty much it. So they've just asked you for the x value. That's going to be 1/2. If they ask you for the actual point on the curve, you just plug that 1/2 back into the function there, and you get the actual point there. All right, if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.